Number 2A, I started by indicating which quadrant is which. Let me just quickly check the homework while you're checking there. Question 2 and question 3. Okay, quadrant 3, quadrant 2, quadrant 1, 2, and 2. Cos in 3 is negative, and the function doesn't change. So it's just negative cos theta. Cos in the first is positive, but because of the 90, it has to become sin. Sin in the second is positive, but because it's 90, it's also going to become cos. Sin in the second is positive, and it remains sin. Then I get an answer of negative 1. You got it right? Good job. Do you all understand? Any questions? Rafilwe, do you understand? I can't help you if you don't ask me. Okay, but you need to tell me which part you don't understand. Because of the 90. So that's the work that we did yesterday. We said if it's 90 or 270 plus or minus, then it's also going to change into the co-function. Because of this graph, you remember I showed you here, if I look at that degrees, let's say it's 20 degrees. If I look at 20 degrees less than 90, it's not at the same position on the curve. Do you agree? So this and this is not the same. Not giving me the same value. But this degrees and 20 degrees before 90 on the cos graph gives you the same value. Because cos is the co-function of sin. A co-function is the function because of 90 and 270. Cos is sin 90 degrees later. If you look, if I show you the negative part of this graph, it will go down again. You see sin starts there. So cos is just starting 90 degrees later. That's what the co-function is. It means it's the same thing, but 90 degrees later. That's why when it's 90 plus or minus, or 270 plus or minus, or anything, any 180 degrees after that, because of the position, the 90 degrees, it will change into the co-function. If we worked with tan's co-function as well, tan will change to cot, because cot looks the same as tan, but it starts 90 degrees later. So its graph will start there. This will be your y-axis. Where here, this is the y-axis, it starts at 0 and 0.
So why differentiation is 90 and 270? What is it?
Because at 180 is the same. It's because of the period of the graph. This one takes 360 to make a full wave, but after 180 it repeats to the negative side. Same with cos, same with that. Are you fine if you were? So you must learn it. Learn it. Okay. You learn the quadrants, cast with the cast diagram, which one is positive where, and then you learn. When it's 180 and 360, it stays the same function. If it's 90 or 270, you change the signs if necessary, and then you also change the function to the co-function. And today we're also going to learn about negative angles. So we're going to see that can happen as well. Okay. B. Review well, look here now. 90 minus, it puts us in the first quadrant, where sin is positive. But because of the 90, we know we're learning it's a co-value, so it's going to change the sin to cos. Okay? 180 plus, that's the third quadrant. Cos is negative there, and because it's 180, it doesn't change the function, it just remains cos theta. So now you have a positive times a negative, which is negative, cos theta times cos theta, which is cos squared theta. Are you fine? Right, then we go to C. Right. You all agree with my quadrants there? 3, 2, 4, 2. Okay. Review where? And everyone else who might still have struggled with it or felt unsure. Third quadrant, tan is positive and it stays tan. No. Second quadrant, cos is negative and it becomes sin. Fourth quadrant, sin is negative and it stays sin. Second quadrant, tan is negative and it stays tan. And then it's going to look like that. Positive stayed tan. Negative became sin. Negative stayed sin. Negative stayed tan. Do you all agree with that? Yes. So just step by step by step. Now when I look at this, I follow the rules. I told you guys to rather put in the multiplication signs where it's multiplied, because you can get confused. Or you must leave this in brackets and that one in brackets where you're multiplying. A positive times a negative is a negative, and then it's just going to stick together, these two. Yeah? A negative times a negative will become positive, and then they just stick together, and then it looks like this. Negative sin theta tan theta plus sin theta tan theta. Now this is the same sum as having negative x plus x. What is negative x plus x? 0. Negative sin theta tan theta plus sin theta tan theta The answer is 0. Can we go on? Third quadrant. What is sin in the third quadrant? Negative. But do you see it's got a square? And the square will make the sign from the quadrant positive. Always. But just the one that we get from the quadrant. No other one. Like if you look at this previous sum at number B, that square, it doesn't make that minus a positive. Because that minus got there because of the signs being multiplied. But the sign that we get from the quadrant will always become positive because this is actually what's happening. We are saying 180 plus is third quadrant sin is negative there, and then I square it. So it's negative sin theta squared. That's why it becomes positive sin squared theta. Okay. The second one, 90 minus is the first quadrant. Cos is positive there, and it's going to remain positive because of the square. But do you see the 90? Therefore, it becomes sin squared theta. This minus is this minus. That square can't change it. So it's sin square minus sin square is 0. But if you don't learn the rules, you won't be able to do it. You won't know it. Okay. B, fourth quadrant, second quadrant, second quadrant. What is sin in the fourth quadrant? Negative, but what does the square do? Makes it positive, so it's just sin squared theta. 90 plus, what is cos in the second? Negative, and does it change or stay the same? Change, so it's negative sin theta. 180 minus is second quadrant. It's positive for sin and it remains sin. Do you see here negative times a positive? It's gonna stay a negative, and nothing can change that. Even if you say sin theta times sin theta, that becomes positive. That becomes sin squared theta. It remains the negative there, and then my answer is minus 1. Okay, are you fine? Then the last 3. 270 minus, which quadrant? Third. What is cos in the third?
Negative.
Negative, but it's 270, so it's sin theta. 270 plus, which quadrant? What is sin in the fourth?
Negative.
Negative, but it becomes cos. 270 plus, which quadrant? Fourth. What is cos in the fourth? Positive, but it changed to sin. Remember, we wrote it down yesterday as well, but it must be in that order. First the sign, positive or negative, then you change the function. Don't do it in a different order because you're going to make mistakes. Okay. Before we get to the negative angles, I just wanted to quickly write numerical angles. And then you can write activity 3, page 145. I'm doing it with you. Mr. Exam. You wrote a test yesterday. You want to write again? We need to hurry through this so that we can have time next week to work out all question papers. So you can see what it looks like when it's asked in a paper. But to get to that, we need to hurry. Okay, do you remember what a reference angle is? I've spoken about it. It's the acute angle. Very good. It's the acute angle that will give us the same value as an angle that's not acute. So you remember the first work that we did in trigonometry, we had that diagram that we drew, and then we said we know that this is actually a very big angle, but we're using the reference angle to fit into the triangle. Okay. Now we're going to do the same, but without a diagram. When we look at sin 310, we want to find sin's reference angle. Now the way we're going to do that is we're going to say I have sin, and then I'm going to put in brackets a sum. The answer of this sum inside the brackets must still be 310 because I can't change the angle. The value that I'll have here has to be an acute angle. The value here can either be 90 degrees, 180 degrees, 270 degrees, 180 degrees, 360 degrees, plus or minus. Now, I want to beg you to not use 90 or 270 unless it's really necessary. You will see the place where it's necessary. We'll get to those sums. But if you have a choice, like with these, always use 180 or 360, because remember, the moment that you use 90 and 270, the function also has to change. So you're putting in extra steps or things to do that creates a possible opportunity for you to make a mistake. Okay. If you take 180 and 360, all you're going to do is change the sign or not change the sign. It will either be positive or negative, and then you're done. Even if that angle is 91 degrees, you want to take 90 plus 1. Don't. Rather take 180 minus 89. 89 is still an acute angle. Must just be less than 90 degrees. That's advice that I give to you. But you will not be penalized using a co-function, and you can still get it right. It's fine. But you are creating opportunities to make mistakes. Okay. Having said that, what do you think can we put in there, plus or minus what, that will give us 310? Okay, why not 180? It's not going to be an acute angle, so you haven't solved the problem. Okay, so it's going to be 360 minus 50 degrees. And now it works exactly the same way as it did when we were working with theta. Now we're just going to say 360 minus which quadrant? Fourth. What is sin in the fourth quadrant? Negative. So it's negative sin 50 degrees. And you can test it. You can take your calculator, check what is sin 310, and then you check what is negative sin 50. Just start negative in the bracket, sin 50. Negative 0.76 gives you the same answer in both cases. The reason for that is, remember, going, or when we look at the negative, that means going in the other direction. So it would go in this direction. Okay? So negative 50 degrees is around about there. Right? Just before it makes the next turn, it will be somewhere there. And there is 310. So do you see it's exactly on the same line? That's why it gives you the same answer. Okay, next one is B, 10, 110. Now you guys remember we in any case only use co-functions with sin and cos, né? Not with tan. What's going to be inside the bracket? 180 degrees minus 70. What is tan in the second quadrant? Negative tan 70 degrees. What's going to be in this one's bracket? 180 minus 85. This is the second quadrant. What is cos in the second quadrant? Negative cos 85. Now, just for those of you who don't listen, you can choose cos 90 degrees plus 5 degrees. It is true you can get to the right answer, but you are risking making mistakes. 90 plus is in which quadrant? Second. What is cos in the second? Negative. And then you must also remember to change it to sin 5 degrees. So the negative cos of 85 will give me the same answer as the negative sin of 5. Okay, both answers would be correct. You make no mistakes. Right, I'm going to do the last one that you can do by yourself. Tan 235 degrees. Let's see if you can do it yourself. Okay, did you get tan 55? Relu, why couldn't we use 360?
Because it wouldn't be like an acute angle.
It won't be an acute angle that you add or subtract. Okay. What? Cotan. Then you would say cot. You're not allowed to use cot. Okay. Stick to tan. I said that at the beginning also because our identities are also just with tan. And everything is going to be thrown together. So we only stick to tan. Okay, you can write negative angles. These three things you're going to have to learn, and I'm going to show you how we're going to apply it in a moment. And then those of you who want to know why it's like this, né? You come to me when we're done. I will explain to you why it's like that. But it confuses learners sometimes, so I don't want to confuse you. If we can just settle saying, I'm going to learn this and I'm going to be fine. You remember the format that we got the sums in or the functions in? It was the 180 or the 360 or the 270 or the 90 plus or minus. So can you see this one is not in the right format? Because the 180 has got a negative there. Do you remember in grade 10 you learned what to do if you want the signs inside of a bracket to change or to turn? I take out a negative. Eh? Now it's still the same. So I'm going to say this is tan, and I take out a negative of 180 degrees minus theta. And this right here is what it looks like when you've got a negative angle. Okay. So you create it by taking out a negative. And now you must know your work, that the tan of a negative is just going to be the negative tan. So that negative is just going to move to the front. So it's going to be negative tan 180 degrees minus theta. Okay. Now after you've done that, you are done with the fact that it's negative. You've sorted the negativity out. Now you do it as you would have done it normally. So you go and you look at that. 180 minus, which quadrant is it? 2. What is tan in the second quadrant? Negative. Now you see there's another negative coming to the front. Now I'm just showing this so that you can see what is a negative and a negative. So it becomes positive tan theta. Okay, and while you're writing that down, I just want to explain to you where the negative part comes from. If I tell you to run positive 10 meters, and I tell you to now run negative 10 meters, what would be the difference in those two? Dankie. Tell us again. The only difference is the direction. 10 meters is still 10 meters. Positive 10 meters would be going forward. Negative 10 meters would be coming back. Okay, or moving in a backwards direction. It's the same with negative angles. If you think about the cast diagram, we move in an anti-clockwise direction. That's the positive direction. And the moment you move in a negative direction, you're moving in a clockwise direction. So that's what it's about. This is not the explanation of these things. Those of you that still want to know, you're going to come to me when we're done. I want to show you another example here. The sin negative theta minus 90 degrees. Can you see that thing does not look right? The thing that's wrong with it is the 90 is negative. Remember, we don't care that the theta is negative. It's the 90. So, we're going to take out the negative. Do you agree? And then I'm not going to write it in the right format. Both are now positive inside, but I want it to be 90 degrees plus theta. That's the way I like it to be. If it was theta plus 90, it's still the same. It's positive, no problem there. What is the sin of a negative angle? The sin of a negative, those things that we just wrote down. It will be negative sin 90 degrees plus theta. Next step. Which quadrant is this? Second. What is sin in the second quadrant? Positive. Now positive is coming to the negative. What is it now? Still negative. And what do you see in there now, Refuwe? It's going to have to change to cos theta. All three of the things in one question. Negative, angle, quadrant sign, and then changing to cofunction. Let's quickly do this one. What is the sin of negative 30? Negative sin 30. What is the cos of negative 40 degrees? Cos 40 degrees. How did we know that? Because you're learning. The tan of negative 150 degrees. Let's do it step by step. First step, you get rid of that negative which you don't want. Okay, what is the tan of a negative? Negative tan 150. Next. Good job. Right, which quadrant is 180 minus? Second. What is tan in the second? Now another negative is joining this negative. So what's it going to be? Positive tan 30 degrees. Do you understand that? Are we going to practice it? There's one more thing I want to show you. One more thing. Okay? You remember we said that the graph goes on in the same way. No? Same way. Over and over and over again. Even if you look at the cos diagram, you can go round and round and round and round, and it's going to keep repeating over and over again. So, if I'm going to ask you for the sin of 600 degrees, should you be scared? Do you agree that if we started at 0 here, it would go around up to 360 degrees? And then I can basically throw that 360 degrees away. And then I start going around again. And that's exactly what I'm going to do. So if you have an angle greater than 360, you take your calculator, you subtract 360, and you throw it away. So this is actually, they are talking about the sin of 600, but they're actually asking the sin of 240 degrees. Can you now go on with it? Yes, so now it's going to be the sin of 180 degrees plus 60 degrees. This is the third quadrant. Sin is negative, so it's going to be negative sin 60 degrees. Let's try just one more. Cos 920. Dankie Carabelu, minus 360 twice, ne? So minus 720 basically. And what do you do with the 720? You throw it away. So they're actually asking for the cos of 200 degrees. And then I can say it's the cos of 180 degrees plus 20 degrees. This is third quadrant. Negative cos 20 degrees. Last one. Last. It's as you think. What is this actually? Is it 720? No. If it was, this is now 720 minus. Look here. Whoops, 360 minus. 720 minus. So even if it looks like this, you just subtract the 360 and throw it away. So they are actually asking you for cos 360 degrees minus theta, or you can say cos 0 minus theta. Both cases will be in the fourth quadrant, where cos is positive, cos theta. Does it make sense? Okay, I want you to do activity 4. Page 148. Number 2 and number 3. Number 2 and number 3. And those of you who want to know why, you can come here. Sometimes people want to know why it's happening. I will tell all of you. I just don't want you, if I tell you, I want you to forget it when I'm done. Because you're going to overthink it. I told the Afrikaans class and they think negative angles are very difficult. I didn't tell your class and you seem fine. You must just learn. Nothing to understand because I didn't explain anything to you. You learn, you apply. Come here, Mama. This one. Minus 360, throw away. Now, if you take that 920, you minus 360. Then it's still to be. Minus again. You throw away. Then you get to the 12.
Ma'am, how did this one, as you can see, this one is negative 30 and then it's negative 7. This one, how is it positive?
learn.
I don't understand here is when we took out the minus, it stayed a negative. But here when we took out the minus, it became a plus, positive.
Because I swapped these two around. So when I took out that negative, it's the 180 that became positive and the theta that became negative. But then I just swapped them around. The order. You see here it's theta and 180. Now I just changed it to 180 and theta. So here when I take out the negative, this one becomes positive and this one becomes positive. You understand? You're gonna have to come to me.
Yeah, I wanted to ask you, how come this is when it goes to the
That's what I said. Do you want me to explain it to you and want to know why it is? But then if you're confused, it's not on me. You learn it. Anyone else who wants to know why cos negative cos is positive? You have to know. Because you must. Look here. When we go in a positive direction, it looks like this. When I go in a negative direction, it looks like this. So look at the cos diagram, it's C-A-S-T. So going in the positive direction, it's everyone positive, sin positive, tan positive, cos positive. Okay. Sin, if I go in, let's consider negative or 30 degrees. If I go 30 degrees into the positive, sin is going to be positive. But if I go 30 degrees into the negative, I'm in cos's quadrant. So it's going to be negative sin theta. Okay, so the sin of negative 30 degrees means I'm going 30 degrees down. It's in the fourth quadrant, that's why it's negative sin 30 degrees. If I take tan negative 30 degrees, it's the same reason here, and it's negative in this quadrant. If I look at cos negative 30 degrees, it's positive is there, negative is here, but this is the cos quadrant. And cos is positive here. That's why it becomes positive cos 30. But now, that's not the big confusion one. The thing that works out, if you look at this one, the tan theta minus 180. Theta minus 180 means theta is an acute angle, and then minus 180 would mean you're there. Okay, so theta minus 180 is somewhere here. Do you agree with that? Now, if we look at the application of it, taking out the negative, tan of a negative is a negative. Then the quadrant is now 180 minus, but you see it's actually 180 plus.
Yes.
But because we're in the wrong direction, this is now our first quadrant, this is now our second quadrant, this is now our third, this is our fourth. Okay. So this is in the second quadrant, and tan is negative when it's in the second quadrant. So that's why the second negative comes here and it becomes positive. Now if you look at this graphically, right from the beginning, this angle was in the third quadrant.
Yes.
So tan is positive there. But without you having to think about it, when you apply the rules, it's going to sort itself out every time. So this one minus theta minus 90. It puts you in the third quadrant. That's why it ends up being negative. Okay, and with all of them. But I don't want you to think about that. When you see negative 135, negative 135, it's going to be negative 90, negative 135, it's going to be somewhere there. So you know it's negative, but the cos of a negative is positive. But now when you take the 180 minus whatever, that puts you in the second quadrant and that makes it negative again. So I don't want you to think about it simultaneously. Think about the sketch or the diagram and of the rules, because you're going to confuse yourself completely. Do you understand what I mean? Okay. But the reason that this one is negative or positive when I go in the negative direction is because of the cos diagram.
Yes.
What's the law? Alles access to the problem. No, maar die functie is. Ik zal hem nooit van zien. Ja, is. Kom maar, ik nee. Nee. Nee, bly eens vir my uitwys. Ek wil hoor van oom E af. Jo. Syge. Waar is die pad? Luister nou vir Spanish. Alles in 'n genuine geluk.